Well, hello everyone. How are you doing? You caught us talking.
Hmm.
Before there, we were conversing about several different things. So, welcome everyone. Monday night to the Physicist and Philosopher Hour. I am the philosopher R. Wayne Steiger, and the physicist is Dr. Claudia Albers.
Hello.
Hello, Dr. Albers. How are you doing?
I'm very well, thank you. And
Good.
you?
Doing good, doing good. Winter is starting to, well, you think about it. Technically, I guess we're still what, 5, 6 weeks away from winter officially?
Yes, it's still fall, as
Yeah,
you call it.
technically it is supposed to be fall. But
Hmm.
winter is here, no doubt about it. I
Yeah.
just want to say hello to everyone in the chat room. Hello, Brenda Fisher, Shannon Kling, all the moderators. Hope everyone is doing well. As we begin to move into the holiday season, Claudia,
Hmm.
you
Yes,
know, you know what
time
that
goes by
says?
so quickly.
Exactly. That was my point. The
Mhm.
year is almost over with.
Yes, and it was just starting the other day, wasn't it?
In my reality, yes.
Hmm.
Not so sure in others. Well, I'd like to welcome as well all of our March on America. Is that right?
Yes, March
Yes.
for America
March for
viewers.
America.
Yes.
Yes.
Hello,
Welcome,
hello.
everyone. Tonight, my beverage is Bengal spice tea. Delicious.
Sounds good.
And it really is. It's the between the nutmeg, the cloves, and the cinnamon, and then they put pepper in there.
Ah, wow.
Exactly. It has
Sounds
that.
very interesting.
It's delightful on the taste buds. It really is.
Ah.
So, just my recommendation. I mean, it's pretty
Yeah,
good.
I used to like ginger tea. I used to drink ginger tea, but you get tired of it eventually. I would move on to something else, like
Yeah, you
rose
know,
hips.
that's pretty good. I hadn't thought
Yeah.
about that.
Mm.
Hmm. I have a friend who's a naturalist survivor, and that's what he'll when he's out in California. That's what they'll actually the rose hips. Yeah,
Uh-huh.
says it's tasty. I don't know. I've never had that. Have you?
Yeah, I used to drink rose hips tea all the time.
It's very healthy for you.
Yeah.
Yeah,
And I used to drink other ones as well. In South Africa, just about everybody drinks rooibos.
rooibos.
Yes, rooibos tea. It's very healthy actually. It's very
So,
high.
what kind of tea is that? Is it like a black tea or a green tea?
It's a herb. It comes from a bush, the
Oh, okay.
rooibos bush. Roy means red, so it's the red bush. Um, and it's high in antioxidants. It has no caffeine in it, so
Wow, what does it taste like?
it's got a very it's actually it's hard to explain, but it's not quite bland. It doesn't have that sharp taste that you get from black tea.
Mm-hmm. Yeah.
It's got a very gentle taste to it. Very
Excellent.
soothing, very soothing.
Something like a chamomile.
It is, but it's a little stronger than chamomile,
Okay.
and it's darker. It looks almost like normal tea.
I'm gonna have to look. Can you buy that in America? Or
I
listen,
think
you
it
can
is
buy everything
available. You
online.
can get it. Yeah,
Yeah. All right. I might look
they
into
ship
that.
it all over the world.
Well, you'll have to send me. I'm going to send you an email so I get the correct spelling.
Okay.
You see, folks, there's 222. Thank you, whoever that was. Here on the Physicist and Philosopher Hour, we also have a bit of etiquette.
Mm.
So we talk about having tea. A spot of tea is always a good thing.
Yes, it is.
Yes, I mean, so we do have I think we have a great decorum here.
Of
Just saying.
course.
So, Claudia,
Hmm.
I was watching before we came on live on National Geographic. They had a documentary that they did on Parker, the new solar probe.
Mm-hmm.
And I wanted to discuss with you because I actually have it pulled up here. So here is the Parker solar probe. We know we're 99 days, 16 hours, 35 minutes, and 55 seconds into the mission.
Mm-hmm.
Claudia, this is what I found so interesting. So this is about the size of a car, a mid-sized car. It'll be there. It's 18 months. First time man has ever done this in getting this a man-made object to the sun.
Yes.
So what I found so fascinating, Claudia, was this. They were talking about the solar shield. Now, they know this is designed to crash into the sun, so at some point, all systems will fail. But as they approach it, and I don't think people realize the sun, 1 million Earths could fit in it.
Yeah, that's right. I mean, just diameter-wise, it's 109 times larger than the Earth.
That's big.
So
yeah. Lynn was watching this with me, and she says, well, that must be quite a view from the front, from the passenger side. I said, yeah, could you imagine? I mean, at some point in time, that's all you're going to see is the sun.
Yeah, if it's got infrared detectors, I suppose.
Oh, it's amazing what they have on this thing. And here's the thing that got me, is this solar shield. This is it's not that thick, folks. And the thing is, Claudia, is that it can, as it's hitting the coronosphere, the instruments are held at a operating temperature of 67 degrees. Now, for me, I'm thinking, if we have that kind of technology, that type of technology that can shield that type of heat, the radiation coming off of our star for something that close, I wonder what else we're using that type of shielding technology for.
Yeah, the thing is, all this about this probe, to me, I mean, I haven't looked at it very closely because, as you know, I've discovered that there's something very wrong with the sun. And the reason for that is the comets, or the Planet X objects that have been going to the sun for thousands of years. And they have filled, and we've looked at the debris, they've filled the inner solar system and the sun's corona with all this debris. So these objects are all around the sun. I mean, they are sending this thing to 4 million miles. That's not quite the sun. That's still quite far off. These objects are closer and moving between the sun and the Earth. So any probe they will send out would be in danger of being destroyed. Plus,
well, this one will be. This one is designed to crash right into the sun.
Yeah, but it's actually likely they will get destroyed way before then, because as we know, the inner solar system is filled with these objects and their debris. So, and the thing is, the heat and the plasma that's coming from off the sun is not due to the sun operating normally. It's actually these objects moving around the inner solar system, and they're making contact with whatever material from the solar system they can come in contact with. And they're getting very hot. This material is getting hot. But as far as I know, the sun is too far gone to actually even produce a decent solar wind. Well, so it may be emitting infrared radiation, but I doubt that it's emitting much more. So if this thing has infrared detectors, but then we could use infrared detectors on Earth, they're not showing us any infrared images of the sun, that's for sure.
Yeah, I don't think it's actually broadcasting yet. It's still, it's not due to start broadcasting. I think they said in the documentary, and I think if I saw on their timeline, this is not supposed to go until about 2020, before it starts reaching perihelion.
Okay.
Yeah.
Well, it most likely will detect the magnetic field. I think it's very likely that the sun is maintaining a strong magnetic field. These objects don't usually lose their magnetic field, well, not much of it, as even after they stop emitting light. So the sun will have still a magnetic field, so that should still be there.
Well, I'm going to watch this. I think it's going to be interesting to see. It's that shielding technology, and they what they said on the documentary is that it uses a special high tech ceramic hybrid material. And I just thought to myself, this thing is just the radiation alone for, if I had my car going to the sun, it would fry any other spacecraft. So I just thought you might find that interesting. Here's the NASA.
Let's look at it some more.
Yeah, please do. This is the animation that is designed, and it's designed to crash right into there. So I think that's going to be interesting. So, Claudia, speaking of NASA, what about that picture there of this new galaxy?
Oh, that is very interesting. Yes, it looks just like a Star Trek Enterprise.
Yes, there it is.
Isn't that beautiful? And the purple color behind it's very pretty too.
Well, and the reason why I'm showing this is the purple. Purple seems to be everywhere.
Yes, it is.
Yeah. I don't quite understand it, but isn't that?
Yeah, well, I would say that it's probably not real, but as you know, I found out that a lot of what they're doing with our skies is not real. You know, they're hiding a lot of things with holographic technology. So it's likely that a lot of these images they're coming up with, these stories, are not real either. They're just entertainment.
Entertainment value alone.
Yeah, they're using our skies for our entertainment now. Yeah.
So I look at it from a different perspective. I look at it as it's like the children's tale of Hansel and Gretel. We are being fed crumbs as we're walking along. The question, as we all know with the story with Hansel and Gretel, they went right into the oven. My point to all this, Claudia, is that I get the sense that they're feeding us just enough to say, yeah, there could be something coming. This one, space storms could cause mass blackouts and destroy computers. It's interesting now. I have a friend in Washington, D.C. Apparently it is on the House agenda next year to be talking more and more about this kind of event. Specifically, they're looking at it from Homeland Security point of view, that they sense that the grid, our electrical grid, is not designed. If a Carrington event that had in 1859 was to happen again, people are apparently listening to shows like this, others, that says, well, it would completely fry our grid.
Yes, but Wayne, they've known this for 50 years and they've done nothing about it for 50 years because they're planning that should actually occur.
Yeah.
Because if they weren't, they would have done something about it 50 years ago.
Well, I think that I can tell this is that in all the madness on Capitol Hill, it is something that, by the way, is getting attention. I thought this one was interesting. Fish recognize their prey by electric colors.
Electric colors?
Yes. There is in the front of the nose, they have found the African elephant nose fish generates a weak electrical pulse to navigate its environment. What they found is that this localization sense apparently shows an astonishing similarity to vision. as a
Oh,
study from the University of Bonn shows.
oh, that's very interesting, actually.
It's fascinating as
It
you read
is.
this, is that fish see in electric colors. How
That's
far out
fascinating.
is that?
That is amazing. Yeah, I like that.
Yeah, this
Yeah,
one,
fish are amazing creatures.
they
It's amazing,
are.
that our oceans are being destroyed by
Oh,
overfishing.
yes, yes.
Most human beings think that fish don't feel, but the thing is, most animals on Earth have feelings. I mean, if you've noticed a dog or cat, you can see they have feelings. So
They
animals
do.
have feelings. Why shouldn't fish have feelings as well? They're
Well,
living.
we know cows do. We know that they try to escape the slaughterhouses.
Yeah.
Yeah. It's like, yeah. So I just thought this was fascinating.
Hmm.
Here is
Very
one.
interesting.
Um, this is I'm going to send this to you because this is an article, Claudia, that it states basically we don't know what we're doing. Um, everything what mankind is doing, that we use elements to generate electrical power that are absolutely detrimental to our species. Speaking of nuclear, when the earth generates a current already, in fact, many people that build homes, one of your options is geothermal heating and cooling.
Mm-hmm. Yeah.
Yeah.
Yeah. The thing is that there are certain groups of people that are making a lot of money out of the wrong elements being used. Plus, they don't want too many of us to live for very
No.
long. And if we do live, they would like us to get ill so that we go to the doctors.
Well,
So it
this, go
this is
ahead.
why things like this happen on this planet. It's not like we human beings would like it to be this way. Normal human beings would like to be healthy, would like to have cheap electricity. And all this would be possible if the powers that be were interested in helping normal people have what they really want and need, but they're not interested.
Apparently, and this article, by the way, it's on medium.com, is one that talks about the fact that in the next 30 years, mankind as a species, we are going to be forced to begin to make the transition to a new energy supply. Here's the dilemma. If we get it right, it's going to be great. If we get it wrong, it could set off a chain of ecological disasters that you you and I may not be here to see the effects, but 50 years to 100 years down the road, they will.
Yeah, the thing is, Wayne, that already in 50 years, the radiation from Fukushima would have spread around the world, and we then dealing with an extinction level event. 50 years is enough for that radiation to reach all around the world. And that's just Fukushima. There are so many other things
So
going
many
on.
folks down in North Carolina, y'all know about the reactor down there. Here's
Mm.
one I thought from Bloomberg that I thought you'd find this one interesting. The air is so bad in California that it's blocking out the sun.
Well, of course, it's not actually the sun, it's the sun simulator. Someone left a very interesting comment under one of my videos. They said, "Oh, I cannot see for more than 1 or 2 miles because of the smoke, but I look up in the sky and I see the moon perfectly." And he added, "It's a hologram." Of course it is. It's obvious. I mean, if you cannot see for 1 or 2 miles, how can you see the moon that's supposed to be outside our atmosphere so clearly?
I agree. I agree. I'm just pointing these things out. NASA now says that they see a cooling trend, not a warming trend. We have done in the last decade, Claudia, a complete 180 now. no longer global warming.
Hmm.
Now, and in fact, I have an article I'm going to send to you. They say that due to new instrumentation, that they're now seeing at the upper portions of the ionosphere, of our atmosphere, we're losing vast amounts of heat.
Hmm.
Now, this is what they found very interesting, Claudia, and I thought of the stellar cores. They're seeing that they never detected this before. And it's like there's a hole, but it's all around the planet.
Yeah, well, I have written several articles about the fact that we are losing atmosphere and we
Yes.
are getting ionospheric holes, just like it happened with the sun. Remember, the sun lost its corona. We saw it losing its corona in SDO images. The same thing will happen to the Earth because these objects will have the same effect on the Earth. They're pulling matter, they're pulling atmosphere, they will create holes in the ionosphere. But that's not why the Earth would cool down. The Earth is, of course, generating more and more energy. As long as it has energy, it will generate more energy, it will come out from the surface of the Earth. And they can also warm up the atmosphere through the sun simulators, which use lasers.
We're going to be talking about that.
Yeah, so they can transfer energy into the atmosphere. They can irradiate the atmosphere of microwaves. That will increase the heat as well, because water and oxygen molecules absorb microwave radiation. So if they say it's going to be cold, it's because they're planning to turn down the temperature through the artificial system they have in place.
Now, go ahead. I'm sorry.
Yeah, because first of all, we have lots and lots of volcanoes erupting. We have the ice melting in the North Pole. That is not due to a planet that is cooling down. And the ionosphere will be more affected at the poles than anywhere else. So if this was due to ionospheric holes, then the North Pole would be getting cooler. And it's not getting cooler, it's getting hotter. That's why we're losing the ice. So they're lying.
Well, what I do know is this, Claudia, is that this is a investment website.
Mm-hmm.
This is dealing with
Yeah, well, they're
commodities.
planning to cool down the planet
My
through
point
the
is, yeah,
sunlight. That's
they,
it.
they said that this could literally happen in a matter of months.
Yeah, well, they know because that's what they're planning to do, perhaps. But don't forget that we've had unprecedented temperatures, like 50 degrees. I want to know it in Celsius, but that's never been experienced anywhere on Earth, in India and Australia, for years in a row. So,
Well, it's changing. I mean, I feel sorry for our listeners down in Australia. You folks are getting hammered. Hail, unprecedented. Tornadoes that they haven't ever seen at the magnitude. So, yes, there's a lot going on. What's your thoughts on dark matter?
well, dark matter is another. I was going to write an article about this. I haven't written it yet. But dark matter is another one of these excuses for the fact that the observations do not agree with the Big Bang model and the idea that everything is due to gravitational collapse. So because the observations don't agree with that, they come up with crazier and crazier ideas, like suddenly there's a huge black hole at the center of every galaxy, and then that's still not enough, so now we have dark matter. And it's like most of the universe is now made up of dark matter. We have a lot more dark matter than normal matter. But the thing is, there is no evidence that there is any dark matter besides the fact that the observations don't fit the theory. But the theory has been falsified already, but they refuse to admit it. So basically, it's another off track, going right off track. It's the blind leading the blind in astrophysics. There is no evidence that there is any dark matter at all. So they continue to come up with stories about dark matter. I mean, particle physics there've been quite a few papers from particle physics where the experiments kept failing to show up that there was any dark matter at all. There's no evidence for its existence.
And I've read those as well. I wanted to point this out to right here. I found this one. They said recently real life research has demonstrated that our sun is currently engulfed in a so-called stellar stream.
Yes, I don't know what research they're talking about, because they refuse to acknowledge that the stellar cores are in the sun's corona, or invading the sun, or invading the solar system. What did they mean by real life research when they absolutely refuse to admit what is patently obvious, and that the solar system is filling up with debris from these comets?
But this is actually backing you up on this. That's what I'm trying to point out.
I know, but I get very upset because they never admit that these objects are even causing any problems to the sun, you see.
But see, they are. And here they are, though. They absolutely are. They're saying that this is what's happening. Stellar streams are populations of related stars that could have once been pieces of a dwarf galaxy or globular clusters that have now been shredded, as they say, by gravitational forces passed through parts of our galaxy. It sounds a lot to what they're saying is what your stellar cores are.
Yeah, but they're not talking about dead stars or making the connection with the fact that our solar system is inside this system. And they're not mentioning anything to do with the dust. They're talking about living star systems.
No, no, they're not. They're actually saying they're dead ones. But I'll send this to you.
They're talking about a dwarf galaxy, that they may have been part of a dwarf galaxy, and they have this idea that galaxies collide and merge. It's a possibility that galaxies collide and merge. And I've come across this whole idea that people keep asking me about whether the solar system may have been a part of another galaxy and may have come in. Well, all that's a possibility, but all of this would have taken billions of years, and so it could have happened within the last thousands of years. And the effects that we are seeing on our solar system have been occurring for only thousands of years.
Well, I'd like to send this to you.
I'll look at it.
Actually, I think when you might have a chance to read it yourself, I think
also,
you may have a change of heart.
When I hear about dark energy and dark matter, I know exactly where they're coming from. And
we'll move on. We'll just. So here's more evidence that things are happening in the Mediterranean area. This supervolcano is now filling up. I was surprised when they said that this thing has laid dormant for a very well. I think the last one, 1538, was the last eruption.
Yeah, well, if there are any dormant volcanoes on Earth still, I'm sure they will not remain dormant for long, because of all the gravitational anomalies that we are having due to these objects approaching the Earth. So they're causing the rogue waves, the tidal events, the ocean recession, the fissuring. And when these objects move over volcanoes, guess what? The magma inside there is going to be affected as well. So it's going to lead to an eruption.
Well, this article is saying exactly that. I find it odd that I live here in Colorado and there is actually a ancient volcanic crater just right up in the mountains at, oddly enough, 10,000 feet.
Yes, you said something about that the other day.
Yeah, it's very interesting. Here's something I thought was really interesting. This is on I can't read the top of that. Earth's magnetic field measured using artificial stars at 90 kilometers altitude. What is so interesting, Claudia, is that they're now advancing laser and actually being able to emulate stars.
Yes. Well, I mean, I've written an article about the technology that has been available for years using lasers. Exactly. Lasers are so powerful that they can do basically what a star can do. I mean, that's what they're using for the simulators.
Yeah,
That's what they're using to simulate the blue sky. That's what they're using to, I mean, you can use lasers to ionize gas, and that's how a star works, through ionization of its atmosphere. So obviously, lasers can be used to produce an artificial star. Yes.
they're doing it.
Yeah, well, they've been doing it for many years now. They're just telling us about it now.
This is from Wash U. I used to live in St. Louis. In fact, I know a lot of people that when I lived there went to Wash U. Anyway, here is what they're finding out, Claudia. I think this one is really amazing, is that not only are there vast oceans now, they are detecting under the mantle, not on the surface, under the mantle. They're also now finding that there's apparently huge volumes of water now that are disappearing, and this recycling mechanism that the Earth has been using, something is, well, as you can see, interrupting that.
Yes, but that may be an excuse for these. I mean, if a lake disappears, and I can quite agree that it went underground. However, when you try to explain an ocean recession event through this mechanism, it just doesn't work. Because if a large portion of the ocean, all the oceans on Earth are connected, so if a large portion of the ocean ends up underground, then you would drop the ocean level globally at all coastlines, not locally, like the ocean recession events that are occurring. And as you know, we're getting the high tides as well as the low tides.
Things are definitely
this may be an
happening.
excuse. I mean, I even read somewhere online when people are saying, oh, certain areas on Earth are having 4 tides per day. Excuse me, the moon does not cause 4 tides per day. It only causes 2 tides per day.
I'd have to see that. I'd have to see some measurements on that one.
I know, but that I actually wrote an article about how the moon's tides work.
Yeah, that would be weird.
Yeah, but of course we're getting more tides because we have these objects approaching the surface of the Earth that are causing local tidal events. That's why we started having ocean recession events in 2017. But of course, they don't want us to know that these objects are out there, just above our atmosphere.
Well, here's one that they've now found the crater larger than the city of Paris beneath Greenland now.
Wow.
And this one correlates with exactly so many other dates that they're finding, anthropologists, as they continue to dig 12,000 years ago.
Mm-hmm. That's interesting.
Same thing at Göbekli Tepe. The same thing that we see down in Chile and Peru. So there was obviously something happened. We got hit. Apparently, we're seeing the evidence, not just once, but apparently in many different places, Claudia.
Wow. That's interesting. Yeah.
Yeah, this one is interesting.
So did they all happen about 12,000 years ago?
Yes, it's
so they may have all have happened at about the same time.
Yes. Yeah. Multiple hits.
Oh, that's interesting.
Isn't it? We have viewers in Germany. Hello to all of y'all in Europe, all over the world. Thank you. Had a subscriber write an email. They're under heavy censorship. It's becoming much, much more. If you say a wrong sentence, they will take you off. You're gone.
Yeah.
So any stories, apparently they're not trying to get this out. It's not in the mainstream news. The Weather Channel covered, but nothing else did. This, low rivers. Now they're in a dramatic drought there, but this one here is beginning now to impact commerce, agriculture.
So that's the Rhine.
Yes. Look at this. Dramatically low water levels are causing chaos in Germany. Drought-like conditions have hit nearly 90%. 90% of the country in 2018. Experts fear that this could be the sign of things to come in the future.
Yeah, so it's raining too little in Germany. It's raining way too much in Italy.
And then you've got the exact same thing in India. Right now, they should be getting their rains. They're not getting them. Who's getting them is Saudi Arabia, Yemen, Iraq.
Did you see the pictures of the desert blooming in Saudi Arabia?
Yes.
It's amazing.
Makes you almost think of something else. Look at this.
Wow.
This is, I think it's Lochhausen Lake, the riverbed. Excuse me. This is
dry.
It's
That's terrible.
Look at this.
My goodness.
So this is this begins to disrupt everything. So this is one, Claudia, that I am collecting. Something I wanted to show you real quick.
Yeah, that is definitely not normal. As you know, this is due to the stellar cores coming in. They emit this light. It's actually not them directly emitting this light. When they absorb atmosphere from the Earth, that atmosphere, when it makes contact with the stellar core, starts giving off energy. So it's actually Earth matter that gives off this light when it makes contact with stellar core matter because of the energy absorption process. And
I want to show you something, Claudia.
That's an amazing color. So we had the pinks for years, and now we're getting purple.
So I collected.
Yeah, there's the pink there.
These are just very recent. People were sending these in. That's a purple rainbow.
Oh, oh my goodness.
Now, if I'm correct, how to get a purple rainbow, isn't that a light shift?
No, it's not a light shift. What I see purple and I see pink.
Well, you can see the blue.
Cyan.
Yeah.
I'm not sure where that comes from because it looks like they are straight lines.
Well, they were actually capturing this, as it was covering the sky. They were trying to show the transition.
I mean, because there are straight lines there, I would say that it's a holographic produced effect. But because usually if it's the stellar cores, it's a natural process. You don't see these straight lines. They mixed all over the place. So I'm not sure exactly what this is. Could be an optical effect. That's a natural process due to stellar core matter coming in. You can see those. Yeah, definitely that. Those are most likely luminescent clouds giving off that light. You can see the color in. You can usually see it at sunset, at sunrise, because the simulators cannot give off a lot of light. Definitely pink clouds, those stellar core. Look at that, purple sky.
Yeah, it's this one here. Where was this one?
Yeah, that's definitely not normal.
Yeah,
no, we're not seeing normal skies on this planet anymore. Not at all.
This is Alaska.
It's getting worse all the time. So look at that. Purple, pink, pitch. The colors that these objects emit that I've seen, and that dirty yellow, I've been seeing it for a long time.
I'm just sending, and of course
I first saw that dirty yellow in South Africa at night, in the sky at night, and I thought, what is going on? Why is the sky looking like that? And the usual excuse is usually, oh, because there's a city there. But I knew in the direction I was looking, there was no city.
This is one of the best ones I've seen. This one clearly shows the striation of a violet light band. And this, as you can see, this is right over the ocean. I think this is Hawaii, in fact.
Wow. Now that purple color is not normal for Earth. Earth is not supposed to get any purple skies at all. In fact, we human beings do not even detect purple very well. We usually, our eyes are meant for the middle of the spectrum, which is the green. So we usually see red and blue. We don't see purple all that well. We don't detect it very well because, you know, our eyes are adapted to the colors of this planet. But now we're getting purple skies. Look at that. That whole forest looks purple.
It looks purple. Yeah. Purples. I mean, and of course we know the snow is white, but this is.
Yeah, because you see what is coming in, the light that is coming in, it's not even a lot of white light. It's a lot of purple light that is illuminating everything. That's why everything looks purple. And I've seen that with what happened in South Africa, where on that day, there was some kind of storm, a dust storm, where everything looked orange.
Ooh.
Everything was in tones of orange. In other words, there was no normal white light coming into the atmosphere at all. Everything was orange. Things that were darker looked darker orange. Things that were lighter orange, but there was not even white. There was just orange.
Orange. That had to be bizarre.
Yeah,
so,
I have that article.
So that's my last one.
Yeah, look at that. That means there's an object that's emitting purple light illuminating our atmosphere.
See, that's what I kept thinking.
There is no other possible explanation for that. No.
I couldn't imagine either. So,
so this is new. I haven't seen purple skies like this before. So this object that emits purple light must be a new arrival.
Well, and this one here, as y'all can see, this was just last Tuesday. You know, they got the same thing. It got on the news.
Yeah, this is not normal. Not normal at all. I didn't think
it was either. So, Claudia, this is one that everyone that saw this was sending me emails and said, well, this is what Claudia has been talking about. And this is the Chinese, their sun simulator that they're building.
Yeah.
And I just thought it was so interesting that when we begin to think about it now, you're hearing stories of different countries building sun simulators.
Yeah, it's like they trying to tell us that, you know, we have some sun simulators in the sky, not the real sun.
Yeah.
But these tokamaks are actually very old. They've been trying this for 50 years or more. And like I said before, I worked on one of these projects.
Yes.
And it never works. It always fails. I mean, they manage steady state for 102 seconds. That's less than 2 minutes. So this is definitely not a working model. And it's never going to be working because the containment always fails. They have to have an electromagnetic field to keep the plasma from making contact with the vessel, which we saw there, the containment vessel.
You actually have a paper right here that you built, right? You wrote a paper. I just happen to have it.
Yeah, there. I actually wrote about this because I know that these things don't work. So, you know, but I don't know why they even keep trying, but perhaps because they still want to believe that the sun is powered by thermonuclear reaction. No star is powered by thermonuclear reactions. We know that. I've written about that for months now. And the reason for that is because we know the sun goes dark. I mean, it did go, we saw it in the SEO images going dark several times. So the sun goes dark, so it cannot be powered by thermonuclear reactions from its interior. And I mean, this thing is supposed to reach 100 million degrees Kelvin, which is supposed to be even hotter than the sun. The thing is, this is a thermal plasma. Thermal plasma means that the plasma is ionized, the atoms are ionized due to heat. But so they become ionized, and you always get atoms that are recapturing electrons. So you're always going to get some neutral atoms, and neutral atoms cannot be kept from the walls of the vessel, which you see there, by the electromagnetic containment. Only charged particles or ionized particles are affected by. I solved some equations for them numerically as a project. I was a student.
Yep.
And they told me it wasn't working.
And one of the reasons you said is that they can't keep it stable?
Well, they won't be able to keep it stable because, as I said, the plasma will reach the containment vessel. And at those temperatures, no material on Earth can withstand these temperatures.
You'd have similar to a meltdown, wouldn't you?
Exactly. So what happens is the moment it reaches the vessel, it damages everything and the alarms go off and it shuts down.
God, I'd hate to be around that sucker.
Yeah, I mean, they managed to keep it steady for 102 seconds, like I said, okay. So they managed to, no neutral atoms managed to get to the walls of the vessel for 102 minutes. That's it. But if you want to produce energy with this thing, you need to have a steady state for many hours, not 102 minutes.
Wow. Now, what continues to fuel this once? I mean, this is not a fusion reactor, right?
It is fusion. I mean, they have a fuel, deuterium, tritium, and you would have nuclear reactions occurring, and neutrons would be given off, but basically it's a fusion reaction. But you know, and it gives off energy, of course.
Right. A whole. So can I ask, what do you do when you get that kind of temperature? Do they have to do a dump on that, or if they know that they can't keep it maintained?
Yeah, I mean, they have to put in power first to get it to reach that temperature. And then once it reaches that temperature, the nuclear reaction will produce the heat. More heat, so it should be self-sustained after a while if you could keep it off the walls, but it's not. And the thing is, like I've talked about this before, in 1972 they came up with a fusion reactor based on lasers. That doesn't have this problem because it's contained by the plasma. The fuel, which is deuterium, tritium as well, is within a plasma. They hit the plasma, and the plasma causes the fuel to implode until the interior reaches temperatures where the fusion occurs. Neutrons are given off, and it's a closed fuel system because the neutrons are used to produce more fuel, and it works on a cycle. You get a couple of cycles per second. So they hit the plasma, it implodes, causes a reaction, neutrons are produced, and then it's allowed to cool, and then they do it again several times per second. And they hit the plasma with lasers. So it's a laser nuclear reactor.
Interesting.
And this doesn't have any containment problems, and they came up with it in 1972. So why would they still try this with the tokamaks that never work? It doesn't make any sense. But you see, the money's going into it. Someone is feeding money so that these experiments keep on being done, even though they keep failing.
Someone's financing it.
Yeah.
Yeah. This is a remarkable paper you did here, by the way.
Yeah, I wrote about the fact that because the sun goes dark, the surface of the sun cannot be at any higher a temperature than 750 Kelvin.
Right in here in this graph.
And that is because well, we don't see the sun in infrared. They don't give us infrared images, but we can see that in ultraviolet light and invisible light, it goes dark during the SDO eclipse season. And if you look at the black body spectrum, so you can see that from comes from the SDO eclipse season, where it clearly shows that the sun's going dark, even though they say it's due to an eclipse. And you can see the fact that the Earth, represented by the triangle, cannot cause these images to occur, because you can see the corona in the middle image. If you compare the two coronas, you can see on the sides, just above the triangle, there's no corona there, and there's no way the Earth could have covered that. So actually the corona shrinks back as the sun goes dark. So this is not due to an eclipse. This is the sun going dark. You can see the structures at the edge. You can see the curvature of the interface between the darkness and the light. This can only be caused by the sun going dark. So we know the sun's going dark, even though they say it's an eclipse.
And I'll actually blow this up for people if they want to.
Yeah. So, and on the right-hand side, yeah. So this is on the left-hand side. You can clearly see, you can see the coronal hole, how it's way above where the Earth would be if this was due to an eclipse. But that coronal hole grows tremendously in 4 minutes without the Earth being able to affect it in any way. So it shows again that the sun is going dark. An object is affecting it, is coming close to it, and it's actually draining the sun's corona. It's pulling the electrons right off it. So it loses its electric potential, which is what causes the sun to emit light. And when it loses that potential, it goes dark. This is why the sun's not emitting light now. It's because it's lost those electrons. The corona, which is rich in electrons, and it lost its electric potential, doesn't emit light.
Well, this is, it's always been one of the more, don't touch this one.
I think it may be emitting infrared light, but the fact that this happens even in visible light, and if you look at the black body spectrum, you looked at the 1000 Kelvin curve, the end of it goes through the portion of the spectrum that says that's visible light. You can see the rainbow there. That means that's the visible part of the spectrum. And the 1000 Kelvin curve, its end is it's within the visible light spectrum. So that means if the sun's surface was at 1000 Kelvin, then when it stops emitting ultraviolet light, it would still emit visible light, because the surface would be hot enough to emit visible light. But the fact that it goes dark in visible light means that its surface has to be at a lower temperature than that. And the curve that would end before the visible light spectrum would be something between the 500 Kelvin and the 1000 Kelvin. So it's something like 750 Kelvin. And that means the surface would most likely still emit infrared radiation. So if we had images of the sun in infrared, we'd probably see that it doesn't go dark in infrared when it goes dark in ultraviolet and visible light. But I cannot be sure, because we have no images of the sun in infrared.
True.
So, but I can say that the surface of the sun cannot be at a temperature above 750 Kelvin from that black body spectrum diagram.
That's just so.
Yeah, and the down there was from what those things that you showed me, where you see they are actually producing an artificial sun, because they're using lasers to ionize a gas that turns into a plasma that then emits this pink light. And we often see the simulators in the sky have this glow around them that's pink. And that's possibly because they're using this technology in these devices that are emitting light. So that means that they are producing artificial suns in a way by using laser technology, because they're ionizing gas and producing a plasma that then emits light. That's how the sun operates.
You get that purple hue. Let me ask you, do you think that this is Do you think that man, in our knowledge, developed this technology?
Well, I think that this technology came from reverse engineering alien technology.
Yeah.
I think even a lot of the technology that we have with computers and came from that as well. I think we would have developed it eventually, but the aliens decided to, give it to us in the manner that they did by crashing their craft and so on. I mean, people had already started thinking about anti-gravity
True.
before this started happening, but then they decided, oh well, forget about what we're discovering. It will progress so slowly, and here we are, the aliens are giving us the technology. But of course, there's always payment that is required.
Check always comes due.
Yeah.
What's this?
Well, that's a laser beam that's coming off the simulator. And that tells us that it's a device. This is not a holographic projection, this particular, I mean, they can produce sun simulations with holographic projections, but this particular one, because it's emitting a laser beam, cannot be a holographic projection. It's actually a device in the sky.
Is this hitting the ground, or what are we seeing?
I am not sure, but as you know, I've also written about the California fires being caused by laser weapons. It's possible that they are using these devices as the weapons themselves, but they could be using other platforms as well, like...
By the way, I find that fire continues to get stranger and stranger. I mean,
yes, and
so how does
not
12
normal when
No.
the houses are destroyed and the trees next to them still have green leaves.
Yeah, I don't know how that happens. And I'd like to know where all the people are. I mean, how do they're saying the number is up to 1,200 that are unaccounted for. And I'm going, how do you miss 1,200 people? I mean, and unless they're
Yeah,
met their demise.
I actually don't know, but what's happening there is very sad and very wrong.
It's, I agree with you 110%. So let's talk about this one, because this one continues to get my attention all over the world. Again, I think about Saudi Arabia and that part of the world. The picture last week was surreal. I mean, they had a swath that went for over 500 plus miles into Yemen and etc., covered in hail.
Yeah, it's unbelievable. I have some images here. These images are from Italy, and you can see the hailstones are quite small, but a huge amount fell in a short amount of time. You can see it looks like snow on the ground. That's huge hailstorm. And it wasn't just hail. There was some, it caused floods. There was so much.
Severe flooding, wasn't it?
Yeah, severe flooding. And this was in October in Rome. And Rome doesn't usually see a lot of rain like this. It never rained as much in Rome as it did in Portugal or England. So this is very strange, definitely not normal. And that's in Saudi Arabia. As you can see, the hailstones were huge. They're larger than golf balls.
Well, here in Colorado, we're used to hell. Hell. But wow, that's I'm looking at this because, as most people know, hail is not, that's pretty well symmetrical. I mean, that's just, it's, so
and it broke the window of that car. That's how you know these are larger than normal hailstones.
So what do you, let's get back to
so what I said in this article is because of the stellar core dust, as you know, we talked about the debris that's coming in, more and more of it. And what's likely to occur is as time goes on, the size of the debris particles is likely to increase. And the reason for that is because when the debris comes into the solar system, it's very low in energy. And it takes time to absorb energy. And when it's very low in energy, its gravitational influence is low. So you won't be attracted to the planets initially. It's only when it starts gaining gravitational energy it starts being able to be attracted by the planet's gravitational field. And the smaller particles will gain energy sooner than the larger particles. So we will get small dust particles in the beginning. And this shows what happens, why stellar core matter absorbs energy, because they're very low in energy. And so they're like a cold object making contact with a hot object. And the colder the object, the more energy will flow from the hot to the cold. And this is also why there's so much energy in the contact regions, because the solar system matter gives off a lot of energy when it makes contact with these low energy objects. But so we are going to get smaller dust particles, and then as time goes by, the particles will get larger and larger. Eventually, we will get asteroid-sized particles.
Whoa.
But as the particle size increases, they condensation nuclei for the formation of clouds and droplets of water. So as the particles increase in size, we get larger droplets of water and more rain, and also the size of the hailstones that form around these dust particles will increase in size. That's why we will get larger and larger hailstones falling. And all this dust creates a lot of droplets of water, a lot of condensation, a lot of clouds that eventually falls as rain. So we're going to get excessive rain wherever, in a lot of areas where this dust is coming in. If it's about the right size, eventually it gets too large and it will just fall down to the surface. But of a certain size and upwards will remain suspended in the atmosphere and create these clouds, create this weather chaos, and create very large hailstones. I'm sure the hailstones will get larger and larger.
Lynn and I were at actually at a Steely Dan concert at Red Rocks. This is a place here in Colorado, Claudia, that you can go outside and see concerts. And we got hit with a thunderstorm that turned into a hailstorm. And I had to literally cover Lynn because my back took a beating. But when I think about hailstones, this is it's not good. We actually had one car completely totaled because of hailstones.
Yeah, wow, that must have been bad.
It was not good. So I pulled this one up because for several reasons. In my files, we're seeing now more and more admission. The Earth is in a dust cloud. We're now hearing that our sun is in a dust cloud. And it's clear to me that they're trying to eventually break it to us that we're in a debris field. That's what I'm going to say. And
okay. Yes, that's a good way of putting it. That's definitely true.
Yeah. And you sent me the stills. I came in and put these through Photoshop, and I was surprised what we saw here.
Yeah, it looks amazing because this object, we looked at the article I did last week. This object is huge, okay? We actually saw that it looked larger than the sun. So these pieces of debris below it, I think they're not actually right below it, because they seem to be a little in front of it. So that's the image you sent me.
Yes.
After you had enhanced
there it is.
Yeah, that object there, or those pieces, are absolutely huge. They are slightly in front of the object, I think, because you can see that top part is partially covering the bottom of the object. But you can see how huge they are. These are the pieces that used to be the outer layers of this object. This is why I call them stellar cores. They are the cores of what was once a living star. And they shared their outer layers of material, because now they cannot even attract their own material. They're so low in energy. But you can see that some of these pieces are absolutely enormous. You can see they're irregular shaped, so they're not celestial objects. They pieces of celestial objects. They're the outer layers of these objects. And then they become a debris field. And so as these objects come in, and they come in as comets, and they make their turn around the sun, a lot of this debris stays behind, even if they move on.
Claudia, do you think that it's just an aberration here? Because I pointed out before.
Do you know what I think? I haven't talked much about that, but to tell you the truth, I think that might be a lens or some kind.
A lensing effect?
Because it seems to be transparent.
Mm-hmm. Yeah, it does.
Now, why there is a lens in front of the detector floating around, I have no idea.
I don't either. I give up trying to figure out what NASA's
because we know we have lenses in the atmosphere, unless they are fooling us, and stereo is not where they say it is. It may be in low Earth orbit. Then there may be lenses there. I don't know, but that looks like a lens to me. I mean, I haven't talked about it before, but I go and talk about the images that we have about the debris. We know we have that debris in this image. Now, this is what bright objects look like when we look at them. You can see what that bright object, it's in the center. Tiny little bright spot in the center there. That's what the object would look like if we are looking through a telescope that's properly focused and aligned. When the telescope is defocused and misaligned, then that bright object looks like those distorted rings, sometimes with a bright spot in the center.
Very good.
Yeah, so when we know that, then we can properly analyze the images that we have, the chronograph images, which the chronograph is a telescope that covers the brightness of the sun, but they have purposely defocused the telescope so that whatever bright objects are there look like distorted rings. So we don't recognize what we're really looking at. And this one is from 1986.
Look at that.
And you can see the sun's corona is filled.
Look at
filled with material. It's everywhere. And these
they shut these
things are emitting light because they're surrounded by coronal plasma that they draw from the sun. And through the energy absorption process, same things happening in our atmosphere, they emit light. Look at it. It's just full of it.
Look at this. Folks, those are objects.
Everywhere.
These are Earth-size objects.
Yeah, at least.
They're not tiny at all. Look at that.
Probably
one of the best ones.
Some of them are actually planetary cores, but I think most of it is debris. It's debris pieces that have been left behind over thousands of years by these comets that are coming from the planetic system. Well, they come in as comets, but they're actually dead stars and dead planets and dead moons.
This is remarkable. The symmetry is absolutely outstanding.
So you can clearly see that it's just...
That's this far out. I saw that and I went, yeah, I know what that is. Look
and this is a close-up where you can even clearly see some of the rings with the dark spots in them. And of course, some of them just look like spots, It looks chaotic, but that's because there's so much of it. And this was in 1986. And they have come up with better ways of hiding what's really there in these images. That's why we probably can see more in the 1986 image than in current images.
I love going through the archives because they can't hide it all. It's there. I mean, if you got the patience and you can go frame by frame.
Yeah, this is an X-ray image, SDO image. And again, you see the same thing. Lots of objects very close to the surface of the sun. They look like dark spots with rings around them. They everywhere. You can actually see them in the part where you can actually see the face of the sun, and you can see them in the corona. They've done everything they can not to give us enough focusing of whatever of the detector so that we don't actually recognize these objects there, but they are there. Now I show what actually is happening here is that the stellar cores are coming in from the planet X system, and they come in a very eccentric orbit, just like the comets do.
Mm-hmm.
And then they seem to stay in a very short orbit around the sun for some period of time. I know the one that causes the STO eclipse season stays for 24 days. And then it goes out into another orbit that may be in another direction. I am not sure, but I know that the two long orbits have different periods. One has 178 plus or minus 1 days, and I think the other one has 183 or 184 plus or minus 1 day. I don't have the data here, but it's something like that. So that's two separate long orbits and one short orbit very close to the sun for 24 days. That's what leads to the STO eclipse season.
Interesting.
So the other ones will most likely come in, like the comets, doing very eccentric orbits, stay with the sun in a very short orbit for a while, come in, sometimes they remain stationary with respect to the sun, making a gravitational connection, then move on to a long orbit again. And this is the debris. These are the irregular shaped pieces. And Scott did this image. He did a really good job with this one. You can clearly see these irregular shaped objects surrounded by coronal plasma in the sun's corona. And these are large pieces, very large pieces.
This is what I want to look at this.
Yeah, look at that.
Holy crapola.
Mm-hmm.
Look at that.
Yeah.
Both
and I don't think we're seeing everything in this image that's actually there, but we're seeing at least some of it here. I think there's a lot more.
You can actually see these objects. I mean, you can see where the pixelization is taking place, but this is quite remarkable here. Look at that. Wow. Okay.
Yeah.
So, you know, this kind of begins to let people know that, you know, it's crowded out there.
It's very crowded in the inner solar system, especially in the sun's corona. And the sun's corona is now filled with this material. So instead of the normal corona that is high in electrons, the sun now has a corona that's been replaced by stellar core matter. So it's no wonder it cannot emit light. The sun still has energy. That's why it's still maintaining its gravitational field and it's still keeping the Earth in orbit around it. But it's lost its corona, basically. Its corona no longer has enough electrons to emit light. Look at that. Again, that's another image that Scott analyzed, and he enhanced and, you know, did his magic with it. He's very good at this.
It's that voodoo that he does.
Yeah.
And of course, we have seen this one many times. Yeah.
But as you can see, there are all the spots right in front of the sun. Can you see that? These are not stars. This is the debris that is filling the solar system, or it was there when this image was taken. Obviously, now we probably have even more than what's even there.
I think you're right. I think this is what's causing.
And you can see a stellar core there moving away from the sun. As I've written, these objects were actually taking coronal plasma away from the sun. The larger ones were causing the sun to have these eruptions towards them. If the sun has lost its corona, I doubt that it can have these explosive events anymore, but they will still be removing material from the sun. They will still be moving towards the Earth. So when we hear about a geomagnetic storm or something like that, what we having arriving at Earth orbit is these objects covered in coronal plasma.
Mm-hmm.
And those are the red skies that are produced by this dust coming in. As you can see, this is not a cloud being illuminated. A cloud cannot be illuminated from below in these colors, especially when they are all intermixed. So what's actually occurring is the clouds emitting light because stellar core dust came in, water condensation occurred around the dust, it formed the cloud, and then the cloud gives off energy because it's in contact with stellar core matter. So it starts giving off light. So it's luminescent.
And we are definitely...
Yeah, that's why we're getting purple skies. It's the same reason.
And purple, I'm going to get us out of here. Yes, let's do that. There we go. We're back. Hello, folks. Well, we were off in the other realm. Things are changing.
They definitely are.
They're changing. I don't know. Purple, I mean, I love the color. They say at one time our planet was actually had a purple atmosphere. Do you think that this was a cycle that the sun may be going in, or?
I don't see how we could have had a purple atmosphere. Don't forget, our atmosphere is actually transparent, but it scatters blue light that's supposed to be coming in from the sun, and that's why it looks blue during the day. But if it was, if it had a color that we wouldn't be able to see the stars and the planets like they usually look at night. So atmosphere is actually transparent, but it scatters blue light. That's why it looks like there's blue light coming from every portion of the atmosphere. So of course now we're not having light from the sun come in. So how are we getting blue sky? Because the simulators are not able to illuminate our atmosphere like the sun did. So the only way we could have a blue sky is they're using laser projectors, holographic projectors, to simulate the blue sky.
Someone wrote, I think it's April, who said, is there a chance this is a reconstruction of the corona, say if there was a large CME?
Yeah, well, the thing is, we've seen what's happened with the corona for years. We have the evidence. I mean, I've written article after article showing that there's no way that we can have. I mean, I've written one recently. I'll show there's no way that we can have simulators and the real sun shining at the same time, because you cannot stop the real sun from being seen from the surface of the earth, no matter what you do. No matter what lens systems you put in place, no matter what holographic projections you put in place, the sun illuminates the whole side of the planet facing the sun, and there's nothing that would stop you from seeing it. I mean, in certain regions, they will put a simulator right in front of you, perfectly aligned. Okay, the sun is there. But the moment you move 2 kilometers away, you would see the simulator and the real sun. So there is no way. I mean, I drew the diagrams. I spent hours drawing the diagrams because I know that some people still believe that there is a simulator behind, the real sun is behind the simulator. And I drew diagrams expressly showing that that's impossible. The real sun and the simulator would be seen. And immediately people would be able to tell which is fake and which is real, because the real sun would look yellow and it would be perfectly circular.
I keep telling people, as a kid, I remember a yellow sun. We
don't have a yellow sun. It's not even circular anymore.
It was yellow. I mean, had a great tan.
Yeah, the thing is, I realize what it is because the mind cannot accept that we have no sun. It takes a while. I mean, it took me a while as well. In the beginning, when I saw all this, I also thought the sun must be behind the simulator. They're just covering the sun, because my mind couldn't conceive of there not being a sun shining in the sky. I mean, I know I had trouble, but thinking about it over and getting the evidence, like in 2011, it suddenly went dark over Argentina. And it only dawned on me when I saw that it had gone dark for 3 hours in northern Russia. And I realized, but wait a minute, if it went dark, and I analyzed it, it was due to stellar core dust coming in, it interrupted the sun simulation. But wait a minute, if the sun is still there and the sun simulation is interrupted, wouldn't we see the real sun? But there was no real sun. And then I found that it went suddenly dark in Argentina in 2011. It's suddenly dark. Do you know that the real sun does not suddenly go dark? Not even during the SDO eclipse season. It goes dark in stages. So, and no eclipse causes the atmosphere to suddenly go from day to night. Suddenly. That's a switch. It's like a switch on an artificial device. Only a switch, an artificial device, can cause sudden darkness. So that means that there was an artificial system over Argentina in 2011 as well, and it failed, probably because stellar core matter came in again. It failed. It went dark. But if the sun simulation fails, why was there no real sun behind it? Because then it wouldn't have gone dark. We would see the real sun. It shows that the sun simulation is replacing the real sun. It's not hiding it. It's replacing it.
Well, it gets even more if you, depending on what your religious beliefs are. But I actually had Jeff Doherty look into this. And so the verse in Matthew that says the sun will go dark literally almost translates out that there's a switch. It's on and then it's off. So if you begin to think it from a philosophical point of view, if you have replete not only in Christianity, but Judaism, Islam, Hindu, I can just go and count the religions that have prophecies or stories of the sun going dark.
Mm-hmm.
So if these stories in fact happen, and let's just assume they did, then I would add to the hypothesis, the theory, it's been artificial all along.
Well, I don't think so. We have evidence for thousands of years that we had a real sun. We have seen the real sun. The Greeks knew there was a real sun there. They knew that it was far away. And then once the lens system was discovered, I think in the 17th century, and they started using lenses, then you could use a lens and know what its focal point is, and you could focus the rays of the sun on a point and get a piece of paper to catch a light. So from the focal point, and you know that happened at the focal point of the lens, so you know that the rays from the sun were parallel. That's the only way it works. So that means that the sun was an infinity. That's the real sun.
No, I get that, but my point is where do you get these stories, for instance, in the book of Joshua?
Yeah, the thing is, the story is in the Bible that the sun would go dark at the end of time.
No. I'm talking about the book of Joshua when they went out there and the sun went backwards.
Oh, that's the sun moving back. That's the earth rotating in the opposite direction. That wasn't the sun.
So if I just look at that from a meteorological point of view, if the earth is spinning backwards, that would have catastrophic effects on the atmosphere.
Well, that should, but apparently it didn't. But that's the only way that it could have happened is if the earth rotated backwards. So it wasn't the sun that was being affected there. And then there was the darkness during the Egyptian Exodus, or the children of Israel leaving Egypt. And there was darkness there, darkness that could be felt, they said. But apparently the children of Israel still had light. Wow. So it didn't affect the whole surface of the earth. So that's, I'm not sure what happened there, but they say it's a darkness that could be felt. So it feels like...
The Egyptians have a good point of view on that. Yeah, they said it was an object that came out of the sky.
Yeah, like some huge cloud, or very thick cloud of something enveloped that area.
The Egyptians, and it's in the bronze books. It's right there in the book. Yeah, it's quite. So someone wants to know if you think that the sun is a closed system.
What do you mean? It's not fed
Says,
by other stars?
thinks the sun's energy is a closed system.
Yeah, the sun, all stars are born with a certain amount of energy, and that energy is unstable nuclei, and they generate energy through radioactive, through fission, really, radioactive decay, like all planets do, like the Earth does. The Earth generates its own energy from its core through radioactive decay, because when objects form, what forms first is the core, which is the densest part. And so what happens is there's a lot of fusion that goes on. We have protons and electrons coming together, forming atoms. The densest atoms end up in the center of the core of that object. And there's no limit to what kind of unstable nuclei you can get. And so you're going to get very unstable nuclei at the core of objects. And the larger the objects, the denser will be that nucleus. So the heavier the nuclei that you're going to get in there. And most of them are going to be unstable. So they're going to decay over millions of years, and they're going to generate energy for that star or that celestial object, the planet, even the moon.
There you go, folks.
It's the same thing, stars and planets. They exactly the same. It's only size that differentiates them in a way.
Size does matter.
Size matters.
Well, Claudia, we've gone well over our normal time, but that's cool.
Yeah, we went on for too long.
No, went fine. So I know this is a holiday week here in America. Thursday is Thanksgiving. So I think this will be your second Thanksgiving, right?
Yes, it is.
Yeah. Little strange custom.
Yeah, it is a little strange, but it's nice. Yeah, it's nice.
Well, yeah, I'm going to be doing
thanks. I think it's a good idea to give thanks.
I think it's wonderful. Yeah, I have actually going to be doing on my radio show, a Thanksgiving, why we should be thankful and how sometimes things can turn very quickly. Okay, well, we'll see you the next Monday night. I believe that then we'll be officially into the holiday season. So I'm looking forward to that. Actually, we're going to be putting up our tree this weekend.
Oh, okay, that's nice.
Yeah, we do a holiday tree. And so we'll start making people feel much more happier.
Okay, sounds
all right.
good.
Well, you and Scott have a great Thanksgiving. All of us, thank you all. This speak favor over your lives. Be thankful for those of you who are in America for Thursday. Those of you listening to us outside of the United States, we just speak Thanksgiving for you. Thank you. We appreciate you coming in. And Claudia, it's always a delight. It really is.
Yeah, it was lovely.
It was. I like that we're getting into the science. We're getting into places that I like thought that when we can look at things that challenges us. And it's one of my great questions. What's the next great discovery for physics? It may be very well stellar cores.
Yeah, the thing is, they discovered them a long time ago. We only finding out about them now because they decided to disclose the information. But I think the powers that be have known for a long time.
Well, you'll always be known in history as the woman who broke the story.
Okay.
There you go. That's your legacy, isn't that? That's a good one. I mean.
Yeah, I mean, because of them, I've been able to basically rewrite physics.
Hey, listen, there are people listening that I know are listening. So they're listening. And yes. All right, folks, be good to yourself. Dr. Albers, always just a delight to be with you. Thank you, Wayne. And again, happy Thanksgiving.
Thank you. Same to you and to your wife.
I'll let her know. She's right outside my office.
You see?
Yeah. Our
She's
house
knocking on the door waiting for you to finish.
Well, fortunately, the house is, situated where my office is on the part of the house where, it's a little bit more quieter. So, okay. All right, everyone, be good. Claudia, thank you. We'll see you next Monday night.
Okay.
Okay, folks, be good. Bye-bye.
Okay.